Thanks for having me today. I started thinking about this Python package when I moved some of my statistical graphics production from R to Python. And I was looking for a library to get a bit deeper into and to make one of my principal tools. And I had two requirements. One is that it should be inspired by the grammar of graphics. And the other is that it should be able to produce interactive graphics for the web. So two words to explain each. The grammar of graphics is this theory of statistical graphics whereby a small set of foundational elements and combinators of these elements are sufficient to create a vast repertoire, if not all, that's hard to prove, but at least a very vast range of different statistical graphics. And I used it in R through the package ggplot. I find that not only very familiar, but also kind of a Goldilocks level between power and simplicity. I think it is here to stay as an idea. As far as interactive statistical graphics for the web, we're talking about not only displaying an image on the web with a chart, but having an active chart where you can select ranges or have tooltips appear or stuff like that. Not full animation, not imagine wind maps or stuff like that, but more charts that respond to interactions from the user. So I look for the answer here and there, and I found this library, Vega Lite, with the companion Vega. It's the main goal of this project is to create a grammar of interactive graphics. What's better than that, right? They took the spirit of the grammar of graphics and say, yeah, if we think really hard, can we find a set of primitives for interaction and a set of combinators so that we can really expand the grammar with its small number of constituent elements to cover a vast array of interactive graphics. And I don't know if the answer is correct. It's still a bit a research project. It has some limitations here and there, but it's very promising. Other prominent projects picked it as a dependency. So I think it has legs, and I find it very interesting. So one of the major artifacts of this project is a JSON subset, a language based on JSON that describes statistical graphics. That gets shipped to the browser, and in the browser there's a JavaScript component that will execute it, not only render it, but also execute it because it has to be interactive. How you produce that JSON doesn't mean that you have to do JavaScript. How you produce that JSON is up to you. You can even edit it personally. Actually, it's not that bad. But a very convenient way to produce these specifications is in Python with alter. So again, this is not my project. Mine is based on this, and it does Vega Lite in Python. So here we get to alter recipes. What is the relation with between alter recipes and alter? First, it uses it. So I mean, it's alter recipes as alter as a dependency. But also, if you think of alter as a fully stocked kitchen with lots of tools and a full pantry, so that you can experiment with all sorts of creations, gastronomic creations, alter recipes is that book of recipes that you go to over and over again, that has the masterpiece, the things that are tried and true, and that you want to pick from for an important occasion. So alter recipes is first and foremost a collection of the classics in statistical graphics: the area plot, the scatter plot, the heat map, the box plot, the autocorrelation plot, the histogram. These are familiar to everybody. They're supported by papers, or they're very common in the literature. If people wanted me to add more charts to this library, I listed a few criteria. You kind of have to convince me that this chart is very important for certain data situations. It has been used before. That's in opposition to other libraries that tend to create a lot of very fantasy-based statistical charts that are not used anywhere else. So really a set of classics. And the flip side of that, you can't produce chart junk. This is a Google search for chart junk in Altair recipes. Actually, this stuff veers into the infographics, so it would be hard to do even in Altair, in pure Altair, but certainly you can't do it in Altair recipes. And I'm not trying to put down people who want to be creative. I think when there is an important occasion, a particular data requirement, and you have time to work on it, you should. I am the first who tries to be original with this presentation. For instance, I have a blog post about a sailing race, and I use lots of polar coordinates because the points of sale are very important for sailing, and those are represented in polar coordinates. But time and again, the major statistical charts are those recipes that have proven most effective. The third reason to develop Altair is that it's just a collection of one-liners. Until the latest version of Altair, you needed 30 lines to define the box plot. And until you run it, it's not really obvious that it is a box plot. Here, if you want a histogram, it's called a histogram. If you want a box plot, it's called a box plot. So it really, you highlight these reference statistical graphics in the API. Also, the signature of those functions, the arguments are really regular, really consistent. There's a data argument. There's a bunch of selectors for the data you want to represent to display. And then optionally, there are some statistical parameters that here are missing. And there's the two graphical parameters. And you see this template repeated again and again. Here we have two variables, X and Y. The rest is the same for the QQ plot. And then we have more complicated things like a multi-scatter plot. Yeah, we have layered histogram. I was so concerned about keeping the API consistent that I developed a package called AutoSig to write consistent APIs. If you just want to do statistical graphics, you don't care about this. But if you are a package developer, please take a look. Let me know if this helps you. It did help me. And just to quickly run through the other charts that I decided to include so far, the area plot, the autocorrelation plot, the smoother, the scatter plot, the bar chart, the box plot, the line plot, the heat map, and that's it. They're all compatible with Altair. You can go from one library to the other very easily and combine them. And that would be it, but I have one more thing that I want to talk about, and it's the following. If you have a kitchen, fully stocked kitchen full of tools to create recipes, and you have a book of recipes with the best ones, what is the next thing that's even better? And the only thing that's better than that is a chef that can pick the correct recipe, the best recipe for the situation. And I tried to write a chef. I'm not sure I achieved it. It's not done by any stretch of the imagination, but it's a function that looks at your data and tries to pick the correct or a reasonable statistical graphics for that data. And it's called Autoplot. And it applies a number of heuristics that I developed over decades of career. I don't want to say how many. And I made an effort to write them together and turn it into a piece of code. So one example of these heuristics, a criteria, is avoid overlap of points. So this is a scatter plot. On one end of this animation, it is plotted without opacity. And on the other end, with lots of opacity, it sends two very different messages. This was not invented by me for this talk. It was at the center of a diatribe between two full professors from MIT and Caltech. So it's important that the graphics doesn't lie to you. Overlap of points can lie. So opacity, when to introduce opacity. And other things, I look at the type and number of variables, continuous, discrete. I look at the density of points, I just said that, and I look at the number of different discrete values for discrete variables, and then there's a few more criteria that are related to colors and faceting. And so, for instance, for a single continuous variable, the strip plot, if it gets too dense, add some opacity. If it gets even denser, switch to the histogram, so a summarized view. For a single categorical variable, use the histogram, that always works. For two continuous variables, the scatter plot, of course, with opacity, if some points start to overlap, and turn to the heat map when it's really, really busy. And there's many of them. Another strip plot with opacity, turning into a box plot at the maximum density, and the faceted bar charts. I can't cover all of them. If you go to the documentation on the left, there's an example link. It shows everything that Autoplot can do in excruciating detail. And for everybody else, it's a starting point. I put the URL on top. Please take a look, see if it can help your statistical graphics production, and let me know if there are any changes, any bugs, anything I need to take care of. Thank you very much.